algebra students, Mr. Lawrence here, and we're going to be working on Excel 10.5, which is all about graphing square root functions. Now, before we actually get to it, we're going to take 2 days on this topic. It's not that hard, but I wanted to review really quick the different types of functions we know. We know a linear function, right? That would produce a line. Yes, definitely, right? And remember, that's not a line. Ugh, now it's a line. An absolute value function, which would look like what? Do you remember? It would look like a V. Yes, these are things that you should know. You should have mastered it. If you've gotten rusty on it, this is something you're going to want to practice because you're expected to know this as you move on through high school math. They're not going to go back and reteach it all the time. Okay, a quadratic, of course we just did those. Those make the nice parabola. We have only mentioned cubics, but cubics are really kind of cool. Tell you what, let me go off on a tangent here. Let me go with y equals x squared and make an input-output table. Okay, and if I do x and y, and I'm going to go -3, -2, -1, 0, 1, 2, and 3. Okay, and then I'm also going to do y equals x cubed, and I'm going to use the same values of x. And watch what happens to see if you can visualize, okay? Oops, I don't know what the heck that number is. Hold on a second. Let me make it look like a -2 instead of a negative squiggle mabopper. All right, -2, -1, 0, 1, 2, 3. All right, so of course you know you're going to get 9 and 4 and 1 and 0 and 1 and 4 and 9, right? And it's going to make that beautiful U shape. It's going to go just like that. Okay? Now, this one is going to be 27 and 8 and 1. I'm just cubing the numbers. 0 and 1 and -8 and -27. So it sure looks like it's going to be that beautiful U shape. The only problem is with that odd exponent, it doesn't have the power to curve it back up. I don't know if you can see this, but it's like this left-hand portion here, right at that point, instead of curving back up and making a beautiful parabola, it's like somebody broke this and caused it to go down. Yeah, that's what's happening with a cubic. All the ones with even powers, y equals x squared, x to the 4th, x to the 6th, will look like the green graph, okay? All the ones that are odd powers, y equals x cubed, x to the 3rd, greater than 1, of course, because 1 would be linear, x to the 1st, y equals x to the 7th, they're all going to look more like the blue one, okay? They might get thinner and more stretched out. So we haven't really done much with cubics. You'll do those definitely in Algebra 2, maybe in Geometry, I'm not sure. Okay, hold on, I went too far. Okay, I'm still in eraser mode. And so the cubic is like the parabola, only the one part is bending down instead of bending up. Okay, now a square root function, that's what we're going to do today. And a square root function is going to look kind of like that. Kind of like that. We'll never go horizontal though. And yeah, there's not an arrowhead on the other end. That is not a mistake. So first of all, let's find the domain of a square root function right here. Now, remember, domain are the possible x values. And you're thinking, well, x can be anything. Oh, no, I don't think it can, because we've got to take the square root. And you don't know how to take the square root of a negative number. You might know you need an imaginary number, but in the real number system, you can't do it. It's not possible. So to find the square root, to find the domain, we have to find out what x values are not allowed to be in here. Well, if I look only at the square root part, the square root of 3x minus 9. What's the smallest that 3x minus 9 can equal? Well, 0. Yeah, 3x minus 9 must be greater than or equal to 0, because as soon as it's less than 0, I get a negative number. I have to take the square root. Now I'm not in the real numbers, I'm in the imaginary. So I'm going to solve this inequality here by adding 9 to both sides. Again, this should be simple. You should have mastered this skill already. It's kind of scary how this all builds directly on the previous stuff we've done. Okay, so then x has to be greater than or equal to 3. Well, x is your input, right? Your domain values. So the domain, and depending how they want you to list it, I'm going to go set builder notation. The domain, all real numbers x, such that x is greater than or equal to 3. Of course, if you wanted to go with interval notation, then it would look like this. So x could be any number from 3 on forever, going in the positive direction. Okay? So all about finding restrictions to find out domain. Now, how do we graph one of these things? Well, let's see here. I've got y equals the square root of x. When you don't know how to graph, it is okay to make an input-output table until you get the shape down. Now, I've kind of already shown you the shape, but that's okay. Now, you notice my inputs, I chose perfect squares. 0, 1, 4, 9, 16, right? Because I'm going to have to take the square root. That's going to make my life a lot easier. So, 0 is, square root is going to be 0, 1, and 2, and 3, and 4. So, I'm going to plot 0, 0. 1 is going to be at 1. 4 is going to be at 2. 9 is going to be at 3. So this is climbing, but it is climbing extremely slowly, I should say. And it'll never go horizontal. It's still climbing. Okay, if you want to verify that, you can go on to Desmos. All right, so that's what y equals the square root of x looks like. What happens if I take y equals the square root of x minus 2? And I can't believe I don't have an input-output table there, but that's okay. I thought I pre-made one. I can make one pretty quick. All right, and now I'm still going to have 0, 1, 4, no, yeah, that's right, 9. I'm not going to put 16 in because it doesn't fit on the graph. Okay, well, if I put 0 in, square root of 0 is 0 minus 2, I get negative 2. If I put 1 in, I'm going to get negative 1. If I put 4 in, I'm going to get 0. If I put 9 in, I'm going to get 1, right? So let's see, 9 is at 1, 4 is at 0, 1 is at negative 1, and 0 is at negative 2. And so you might be able to see this better on Desmos if you put both equations in, both functions in, but the entire graph shifted down too. What do you suppose would happen if the equation had been y equals the square root of x plus 4? Well, yeah, that curve would have shifted up 4. It's called a vertical translation, okay? That, I believe, is it for today's video. So we learned how to graph, we learned how to identify domain, we learned how to graph y equals the square root of x, a square root function, and what happens if we add or subtract outside of the square root function. It causes a vertical translation. In other words, the curve shifts up or down. All right, that's it for the video. Mr. Lawrence signing off. Have a good day, everybody.